What is up, y'all? Today we're going to be going over a problem from Grind 75 called Maximum Profit in Job Scheduling. It's a hard problem, so luckily I'm here to save the day. In this problem, we have n jobs where each job is scheduled to be done from start time I to end time I, obtaining a profit of profit I. You're given the start time, end time, and profit arrays. Return the maximum profit you can take such that there are no two jobs in the subset with overlapping time range. If you choose a job that ends in time X, you will be able to start another job that ends in time X. So in this example, you have the start time, end time, and profit arrays for each job, and then visually you can see when it's laid out on a timeline that picking the blue job and the purple job will yield you the maximum profit because those jobs don't overlap and combined they have the maximum profit. So how can we do this programmatically? Well, here's a high-level approach. Set the start, end, and profit lists together and sort by the end time increasing. So once you have this, you have all the information necessary for each job. Call this array jobs. Initialize an empty, and by empty I mean a non-type array with who has the length of the jobs array. And make the first element be the profit of doing the first job. Because the profit up until the first job just has to be the profit of the first job itself, right? There's nothing before that job, so you can just initialize that. That's their so-called base case. And this array will represent the maximum profits up until and including uh, the index of the job that represents. So now, for every subsequent job j, find the latest job k that ends before j starts. And as you're doing that, you have to compare two outcomes. The first one is when you include the job j, which means taking the profit of job j and the maximum profit up to and including job k. Oh, and to clarify what job k is, it is the latest job that ends before job j starts, which means it's the latest job that you can also do if you do j, right? So it makes sense, right? If you take the job j, it means you're taking the job j, but you can't take anything um, until you hit job K, right? Until you move all the way back to job K. And what is the maximum profit of the job uh, up until job K? Well, that's represented by the array that we're building up here. And then the second outcome is to exclude the job J and just take the maximum profit up until the job before it, right? Once you have these two values, we can set the maximum job profit of job J to be the max of the include and exclude values. And at the end, we simply return the last entry in the maximum profit array, which represents the maximum profit up until and including the last job. Now let's go through a step-by-step walkthrough. So in this example, we're given these start and end profits. Here we've zipped all three arrays. Here we've sorted by end time. And here we've initialized the non-type max profit array with the first entry being 20, which is the profit of the first job. Now, I've started my cursor on the second job. This job has a start time of 2 and an end time of 5. What is relevant here is the start time of 2, because if this starts at 2, we can't use this job because it ends at 3. And because there's no more jobs before that, we can't use any job before this if we take this job. So what will the maximum profit of the job at index 2 be? Well, that just the maximum of the including the job and excluding the job. So including the job, you just get 20. you aren't able to use any job before it. Excluding the job, you still get 20 because it's all it is the profit up until or before the current index. So taking the maximum of these, you get 20. And you move on to the next. So now this job starts at 4. Oh, my bad. Starts at 4. So you want to take the max profit of jobs that end before 4. Well, this one ends at 5, so we can't do that job. This one ends at 3. Yep, so that's valid. That is the latest job that ends before 4. And what is the max profit up until that job? Well, that value is simply 20, right? So if we take this job, we can take the $70 in profit and the 20 profit we have from the maximal job prior to this. So including this job, it's 90, and then excluding the job, it's simply one before that, right? Which is also 20. So now the max profit up until this job is 90. And now we move on to this job. The start time of this job is 6. What is the latest job that ends before this job? Oh, it's right. It's this one right here. And we know that the max profit up until this job is 90. So including the current job we're on right now, we can do 60 plus 90 is 150. And then excluding the job, we simply have to settle for the max profit up until and including the job before it, which is 90. What is bigger between 150 and 90? It's obviously 150. So we can go ahead and fill out this entry. I'm just gonna do my best. And we move to the last job. This job starts at 3, but it pays 100, right? So let's see what happens. If we take this job, we can't do this, it ends at 9. Can't do this because it ends at 6. Can't do this, ends at 5. We can't do this because it ends at 3. So if we take this job, our total profit will be 100 plus 20, and 20 comes from this, not this. And excluding the job, we just take the profit up until the job before it. So that is 150, as indicated here. So obviously excluding is bigger here with 150. So we simply fill in 150 for this last entry. And now the algorithm has terminated. There's no more jobs up after this. So we can return the last entry in the max profit array, which is 150. And yep, that concludes the walkthrough. Please feel free to attempt the code and yeah, let me know how it goes.